Question 6. So make up your own events to correspond to those indicated on the probability scale for you below. So they've done G for you. They said the day after Wednesday will be Thursday. That's certain. Oh, can't spell. That's certain. So that's where G is. D could be heads on a coin. So anything that's 50-50 chance. Something that's impossible. I think I used this in class. The day of the week not ending in Y is a good one for that. Again, you might have a different one. Something very unlikely here would be winning the lotto is pretty unlikely. Third, let me think. This would be something like rolling 5 or 6 on a dice. Because that's 5 or 6 is 2 numbers out of a possible 6 numbers. So 2 numbers out of a possible 6 numbers, that's the same as 1/3, and that's about where it is here, okay? Something that's very likely, rain in the next week is probably pretty likely. And here, so this is something that's likely. Can I think of anything? So what's that? 0.65. Oh my god, drawing a total blank on something that's likely but not very likely. It's about 2/3. Something that's split into 3. I don't know, you could do something like the probability that someone in this class will have a birthday this week or will have a birthday in the next 2 weeks. That might be an option. I mean, you could stick with the dice example and say like rolling 2, 3, 4, or 5 on a dice. That's 4 of the numbers on the dice out of 6, which is 2/3. And that's approximately where that is, about 2/3 of the way down the line. So yeah, anything that would fit under those descriptions. If you want to check if Miss Stack is there, you can ask her if you feel yours fits, and if she isn't, you can leave a comment on Schoology with your answer and say like, oh, would this work for F? Would this work for D? Something like that, if you're not sure. So then question 7. So Liam says that the probability that he will fail his history exam is 13/10. What is wrong with this statement? So if you do 13/10 into your calculator and press SD, you get 1.3. So he is saying that the probability that he will fail his history exam is 1.3. If I write that as a percentage, he's saying he's 130% chance of failing his exam. What's wrong with his statement is that probabilities only go up to 1. Okay, so the highest probability you can have, you can see it up here. The highest probability you can have is 1. It's not possible to go beyond 1. So that's what's wrong with his statement. And this is going to be a similar thing. So for question 8, Anne tells her friend that the probability of her getting married is minus 0.5. Explain what is wrong with this statement. Okay, so again, the smallest probability, if something's impossible, the smallest probability is 0. Okay, and if you look at a number line, let me just draw a number line here. So here's 0, and let's go like 1, 2, and then on this side it would go -1, -2. Okay, so minus 0.5 is here. Okay, but probabilities don't go any smaller than here. So you can't have a negative probability or a probability with a minus, because probabilities start at 0. All right, so that's the homework. And so like I said, if you want to go through that at your own pace, pause it wherever you need to. And if you're not sure about any of your answers to question 6, just ask. Okay, if you can ask Miss Stack, great. If not, you can pop me a message on Schoology and I can check it for you. Right, so we'll have a quick look at where I wanted to go after this, which is here. Okay, so the next thing we're going to do is relative frequency, otherwise known as experimental probability. Okay, so that's going to be your heading. Now, the experimental part is important, okay, because this is based on doing the experiments. Okay, so whatever it is you're trying to figure out, you need to actually do the experiments, okay? Now, you're not necessarily going to do all the experiments because they can, like, sometimes they're just done in the question, but they're all based on actually doing the experiments, as opposed to other questions, which is called theoretical probability, and that's where you just do it based on theory. So let me try and explain. I asked you over last week, flip a coin, what's the chances of getting tails? And you were all able to tell me that it was a 50-50 chance, or it was 50% or 0.5 or whatever version we used, which is great and correct. But when you're doing experimental probability, this is where I give you a coin and you flip it 50 times. So if you flip the coin 50 times, according to what you guys told me last week, you should get 25 heads and 25 tails, because you said it was a 50-50 chance. Now, in theory, it's 50-50. But in practice, when you actually do it, you might not get 25 heads and 25 tails. You might get like 30 heads and 20 tails. It might not be exactly 25-25, okay? So that's what experimental probability is about, where it doesn't necessarily follow what you think it should be because you're basing it on an actual experiment. Is that okay? So we're going to do one of these experiments. I have a little formula here. This is how you calculate it. So like all the probabilities we've been talking about so far, do you remember I said they can be written as fractions? And if you want, you can then convert that into a decimal. And if you want, you can convert that into a percentage. Okay, I've shown you how to go from fractions to decimals on your calculators. Okay, and we'll talk about percentages again. So that's why this thing here is a fraction. Okay, so the frequency, or the number of times an event happens, over the total number of trials. Okay, so let's say we do this, which we are going to do, and I ask you to flip the coin 100 times. And let's say you get 52 tails. Okay, and I ask you for the relative frequency of getting tails. You simply create a fraction. You put the tails over the total number of flips, and you can then type that, if you want, into your calculator using that fraction button again, this one here. So you type it into your calculator and it gives you 13/25. Okay, and if you want, again, you don't have to. I press the SD button and I can get that as a decimal, 0.52. Okay, so you do this thing I'm talking about here, which is relative frequency, by just creating a fraction. So the number of times the event happens, that's the event you're interested in, over the total number of trials. Okay, so I'm going to draw your attention to this table here. Okay, I want you to put this table into your copy, relative frequency experiment. So copy this into your copy, please. And then I want you to flip a coin. Ooh, sorry. 30 times. And I want you to record the number of heads and the number of tails that you get after flipping the coin 30 times. So it might be 16 heads and 14 tails and so on. Okay, then you have to tell me what's the total number of flips. So that should be 30 if you've done it right. And here we're going to create the fractions, the relative frequency. Okay, so this is heads. So how many heads did you get? Whatever that number is, over 30. And here, this is tails. How many tails did you get? Over 30. Okay, so you can go ahead and do that now. Flip it 30 times and figure out how many heads and how many tails. Okay? Now, once that's done, we're going to all come together and fill this table out. So whoever the first student is in the class will give us their details and we put it in to the first row. Okay? The second student will go into the second row and so on. Okay? We fill up this table and down the bottom we want to calculate our totals. Okay? And I'd be very interested to see if there's any difference between the relative frequencies that you calculated and the relative frequencies that you calculate when you include everybody. Okay, so if everybody in the class is going to flip the coin 30 times, you're going to have an awful lot of experiments going on because the first student will have done 30, the second student will have done 30, so that's 60. Third student will have done 30, so now we're up to 90 experiments. And then the fourth student will bring us up to 120 experiments and so on. So I'd be interested to see what the individual relative frequency is and then see if there's any difference when you bring it to the total relative frequency. Okay, so if you can go through that experiment and complete the cumulative or the whole class relative frequency table and then see what your numbers are and see if you can make a comparison with what you think the frequency should be. Okay, so when you flip a coin, how many heads should you get? How many tails should you get? And which one is closer? So is this one closer to what you should get? Or is it actually the totals down here that are closer to what you should get when you flip a coin? Okay, so that's it for today, and you don't have any homework. We will go through some other experiments, ones that we're not going to do the next day. Okay.